Okay, so I'm sure we're all feeling a little better about that chapter now with some nice meaty calculations to work on as opposed to just some definitions. So that's good, positive thing. But there are some more definitions we want to talk about, and I want to focus in for a little bit here, at least on some of the terms, and recognize I've probably been using some of these terms without maybe having completely defined them. But there's a few things we want to look at here, and I have an equation describing a reaction that will help us identify some of the things we want to talk about here. So one of the ways we can classify different chemicals is whether they're made up of single elements, multiple elements, all the same element, different elements, and there's a different term that kind of goes along with each one of those, and I have some of that identified here. So looking at this equation, we start with 2Al, and this is a solid. So this is an example of what we would call an atom. So something is an atom, or we would describe it as atomic, if there is only one chemical symbol in its formula. So we would start off this equation by saying 2 aluminum atoms. Right? Now, the parenthetical expressions here are phase indicators, so the S here means that aluminum naturally occurs as a solid. So this would be 2 aluminum atoms in the solid state. Now, since there's only one atom of aluminum here, we could also refer to this particular aluminum compound as an elemental form of aluminum. So something is elemental, or an element, if it has one type of symbol, right? But there could be more than one of that particular symbol present in the compound. So aluminum is an atom because there's only one, and it's an element because there's only aluminum in there. Right? Now, if we move on here, the plus is often read as reacts with. If it's on the left side of an equation, those are usually called the reactants. So 2 atoms of aluminum react with 3, and then Br2 here is what we would refer to as a molecule. Now, a molecule contains 2 or more atoms. In this case, they're both bromine, but this would be a bromine molecule. So this is 3 molecules of bromine. And there's an L there after bromine, meaning bromine is in a liquid phase when it normally occurs. So we wouldn't want to refer to this as an atom. There's a difference between an atom of bromine and a molecule of bromine. An atom of bromine, you wouldn't have that 2 that follows it, and I should probably point that out a little more clearly. The subscript here indicates how many of the preceding atomic formula or elemental formula are present. So no subscript means 1, so you don't write into 1s, you just know that the 1s are there. So this is 1 aluminum, but this is 2 bromines. That's what makes it a molecule as opposed to an atom. Now, the only type of symbol present there, though, is bromine. So this is also a way to describe an element. So the bromine here in the equation is a molecule, but it's also an elemental form of bromine because there are only bromine atoms present in that particular molecule. Okay? So elements could be atoms, could be molecules, right? But atoms can't be molecules or vice versa. Now, the arrow, this is often read as produces or yields. So you could say 2 atoms of aluminum react with 3 molecules of bromine to produce, right? And then our product here is aluminum bromide. In this case, aluminum bromide, right, it could be classified as a molecule because there's definitely 2 or more atoms in there. But more commonly, we would classify aluminum bromide as a compound, which contains 2 or more different types of atoms. So in this case, there's aluminum in there. There's also bromine in there. There's 2 aluminum atoms and 6 bromine atoms. But together, all of those make up the compound aluminum bromide. Now, this also is a molecule. So molecules can be compounds. Compounds are always molecules, but sometimes a molecule wouldn't qualify as a compound, like bromine. This is not a compound. This is just the molecular form of bromine. Compounds can never also be elemental because you've got to have at least 2 different elements in there to qualify as a compound. So I know this is complicated. There's lots of little details there, but this is something to kind of keep in mind. We use very precise language when we're trying to describe chemical processes and reactions. And if you say molecule where you mean atom, it's really possible that you completely change the meaning. So something worth thinking about is when to apply each of those labels. Now, another example here, when we start to write out formulas, we start to write out some more complicated formulas for things like compounds where there's lots of atoms going on. There's a few there, well, lots is maybe an exaggeration. There's a few different ways we can express that information, and each one provides a little bit different set of information. So as an example, I'm going to use ethanol, which is alcohol, the kind you would drink. It's a fairly simple molecule, but it makes for a good example here. Now, the molecular formula for ethanol, molecular formula just describes atoms present. So this is only telling us what atoms are present in that particular formula. So the molecular formula for ethanol is C2H6O. There's 2 carbons, there's 6 hydrogens, there's an oxygen, right? And that gives us some good information about that molecule. But maybe we want to express more information about that particular molecule. We might use what's called a condensed formula, and a condensed formula presents some information about how the atoms are connected. So I'm going to put some connectivity. There's no M there, 2 N's. Some connectivity info. So the same compound, ethanol, you might write it as CH3CH2OH. So it's still the same formula. There's still 2 carbons, there's still 6 hydrogens, there's still 1 oxygen. But what we're shown here is 3 hydrogens are associated with one of the carbons, 2 hydrogens are associated with another carbon, and one of the hydrogens is associated with the oxygen. So we're starting to get some information about the way the atoms join up with each other here. And we could go even further and show a structural formula of this particular compound. And in a structural formula, we're actually going to show some bonding information. So I'm just going to write show bonds. So a structural formula for ethanol might look like this. Here's that first carbon that is associated with 3 of the hydrogens. That second carbon is in the middle of the molecule. It's associated with 2 of the hydrogens. And then the oxygen on the end is associated with the last hydrogen. So now we can see the way the atoms are connected. We can see somewhat what the structure of the molecule is. And this can get even more complicated because we could put 3-dimensional information in here. We could make the angles be accurate as to how they are in the actual molecule, and some other things like that. Okay, so that's something we'll come back to quite a bit throughout the semester because, right, this is part of what we'll talk about is what kind of information is present in each of these formulas, how we can figure it out, what kind of things we can calculate from it. Okay, now from there, we want to move on and start to talk about what is probably the primary issue of this chapter, which is the formation of ionic compounds. So that's a big topic. So I think this is a good place to stop with this video. We'll pick up with formation of ions and then in particular naming of different ionic compounds in the next video.